Discovery, go at throttle up.
All right, another day of Kerbal, Rocket Launch, chocolate sauce. Anyway, and then Pod's coming back home. Are you ready? Are you happy? 2 landings today, and they're both on land. Indeed, but it's Wings Wednesday. No. It is not Wings Wednesday. It's just Wednesday. Jeb comes home today. That's right. That's right. It is not Wednesday, my dudes. Launcher posted this today, some data on their firing tests. Dude, all right. Yo, look at this. Wow, where'd you get this? Yeah, it looks military, definitely military. Dude, all right. Hey, all right. Melvin, you guys are so dumb. The first thing in the list, go right through Falcon's Maze. What is the G denoted behind PSI? PSIG, absolute pressure. Yeah. So, we haven't heard that song in a while? Yeah, because I can't listen to it. PSIG. Takes a good 5 seconds to get the full thrust. Yeah, look, see? There's your overpressure event. A little bit of thrust and then... Nice. Greetings, Professor Falcon. Shall we play a game? How about a nice game of chess? What tested that? That's Launcher. That's pretty cool. PSI gauge, Novus? Explain. God, that's such a good movie. I love that movie. It's a fantastic flick. You're telling her all of our best tricks, Mr. Potato Head. Mr. Potato Head, backdoors are not secrets. PSIA is absolute. It's relative to atmospheric pressure. Oh, yes. Yeah, that's right. I got it confused. I always do that. I always screw up some mundane detail. Have you seen the sequel to War Games? There was no sequel to War Games. Nope. There was no sequel. Okay. I didn't see it, therefore it isn't there. Yeah, that guy's in space. When is the next State of the Stream? Why do you ask? Those usually happen in January. Engineers are not good at dealing with customers. Just asking. Yeah, they usually happen in January, dude. Why? Is there something you want to see changed? You started on time for once. I don't see anybody thanking me for being up 6 hours early last week for that Starlink launch. Oh, EJ, you're so early. Oh, thank you. Thank you for covering the Starlink launch. Nope, it's always, oh, EJ, you're late. Oh, wow, you were actually on time today. Nor do I see anybody being like, oh, EJ, you streamed an extra 5 freaking hours today. Oh, thanks, EJ. Thanks for streaming so much. I really appreciate it. No, it's just you're late. That's it. That's it. Just you're late. That's all. That's all I get. All right. All right. Okay. Okay. Do you want to waste my time? Okay, pussycat. Jeez. Okay. I don't know if I conveyed that point across well enough with the Scarface reference, but that was a joke. You want to waste my time? Okay. No? Alright. Cool. Based on our chamber discussion yesterday, would you happen to know a good book or online resource about combustion science? Rocket Propulsive Elements, 9th edition by Sutton. That's where I learn. Actually, I have the 8th edition. Ah, I see. Do you know what your problem is, pussycat? You got nothing to do in your life. Just sit here and wait for me to come home and stream. Huh? Huh? Alex? No? Alright. Do you want to play rough? Okay. Say hello to my little friend. No? Scarface? No? Anyone? No. Alright. Okay. Alright. Let's do this. So we got about, I don't know, hour and a half. Isn't this the mission mode save? I don't know, is it? First you get the Kerbucks, then you get the launch pads, and then you get the rockets. All I want is what's coming to me. And what's coming to you, Tony? The moon, chico. The moon. All I have in this world is my boosters, and I don't jettison them for nobody. Nobody, Frank. Nobody. We're in engineering mode, dudes. Sorry, I'm busy launching a Kistler K1 on a Titan 4. Ew. Ew. It's kind of gross. When AJ goes to the full screen, that means you're in trouble, Frank. Do you know what a hassa is, Frank? It's a pig that don't fly right. Neither do you, Frank. God, I love that movie. Oh, that movie's so good. Fight you, it works? No. No. Alright. So, the hold down points. Hold down points for the new rocket here. Guys, I had a Doc Brown moment last night, and it might work, it might not. Listen up. I was putting the dishes in the dishwasher last night. All right? And I was taking dishes out and putting dishes in, right? We're taking a clean load out, putting new dishes in, right? And I grabbed some plates to put in the cabinet above the dishwasher with the cabinet open, reaching down underneath the dishwasher. I hit my head, I fell, and I had a revelation, a vision, a picture in my head of new hold down points. Oh, you think I'm kidding? Yeah, you think I'm kidding. No, I'm not kidding. I actually did. It was terrible. Yep. Oh yeah, I got a nice gash on my head. There was blood everywhere. It was lovely. Yeah. Yeah, that's why I'm wearing a hat today, because I don't want my headset riding forward and hitting, just rubbing on that scab. Yeah, that's good. So, I actually did short time after I finished picking up all the blood. It looks like frickin' American Psycho in there, or looked like it. After I finished cleaning up all that, I actually had an idea for the hold down points. Maybe I was just trying to keep my mind off of the fact that my kitchen looks like something from Silence of the Lambs. That was good. No stitches. Nope. I hit it fortunately, I hit on the corner of the cabinet door, which, you know, it's just a little puncture. You know, it's okay. Your boy's got a thick skull. I don't know if you knew that. Now you do, if you didn't realize. Yeah, exactly. That's the thing. You ever get hit in the head, it bleeds everywhere, because there's a lot of blood up here. Yeah. So is the cabinet plumb now? I don't know what the cabinet is. I wasn't worried about the cabinet. Were you listening to sports? No. Massive release of hot air. Yeah, I gotta let all the freedom out, dude. So as I was picking up that mess, I actually had an idea for a new hold down point that could actually work, like as a hold down point, but not like 100% on it. But these are very good. These things do work. And the physicsless parts seem to be the way to go. If you're wondering what this setup is, this is the rocket that has the A on it. This is the new design that I'm working on here for a new launch vehicle for the mission mode save. I am doing it in engineering mode as kind of a way to get back into playing KSP. It's not the flux capacitor, but yeah, I got chapped lips. Chapped lips in the middle of spring. Alright. Sure, why not? So, I'm not sure if the new hold down points will work or not, but I figure, you know, we got a little bit of time before Transporter 5 and whatnot, so we might test them. These hold down points are actually based off of, they're based off of Falcon 9. I basically found a way to possibly be able to replicate them. And Falcons, it might work. I don't know. I know it'll hold it up. At least I think it will. But it might not work. It might work. I don't know. Let me see. Let me see if we can find a picture of the hold downs in my repository of Falcon images. Nope. Do the strong points on the booster jettison off at some point, or do they stay on the booster? The hold down points on Falcon 9, they ride with the vehicle. There they are. See the pin? That's the hold down. There's 4 of them. 12, 3, 6, and 9. See them right there? And then SpaceX's hold down point is kind of like, picture like 2 fingers that kind of go like this, right? They kind of do that, right? Around that piece right there, right? And then they, when the thing goes to launch, they let go. Kind of, Pigsig, yeah. See that right there? And then here, let me see if I can find a picture of the hold downs. The GSE side hold downs. No. Bad Air Force. Bad Air Force. So there they are. See the little fingers right there? 1, 2, and then there's 2 more down the bottom. 3 and 4. It's 2. They're like this, and they grab the hold down point like that, and then they let go. The gif of them moving. Is this the one that makes everybody sick? Dude, for some reason, staring at this thing long enough makes me want to throw up. I don't know why. Yep, see? Thomas, you know what the funny thing is? I actually figured out a way to make this. I can make this with the hybrid tech. It's just going to be too many parts for a launch pad, but I can make that. No problem. Yeah. Yeah, see, the hydraulic pushes, and that moves the whole thing back. Moves it out of the way. Make it stop! Alright. Yeah, seriously, that one makes me want to throw up. And also when they're flipping Falcon 9, it's bolted, they bolt the crane to the hold down point. Just on a side note. For anyone that cares. So I figured out a way to do this. Figured out a way to make this work. See? There it is. What was that picture of the Falcon 9 in the road? This one? Nuclear, this was coming back. This is coming back from Port Canaveral. This is the south gate of Cape Canaveral Air Force Station. Here, let me show you. Boop. So Falcon 9s are recovered on the drone ship, right? And then they're brought through back into the Cape, back up to Kennedy Space Center, believe it or not, with the shuttle transporter. That is the former shuttle transporter, dude. I don't know if you knew that. I know some of those pictures. I think Goalie did take that one. That picture is in this parking lot right here. So this is the south entrance to Cape Canaveral Space Force Station. That's the soft gate right there, and then the hard gate is up here. That's where the guys with the big guns kind of chill. True story. So, SpaceX operates over here. And now keep in mind, this is a super old picture at this point. You want to see what this looks like now? Ready? Whoop! Yeah. Florida put a gigantic port here, Port Canaveral, and SpaceX has a huge berth at that port. This is an older picture, but there's Doug and Shannon right there, or Bob and Megan, either one. And this is where they take the rockets, right? You can actually see that this is SpaceX stuff here. There's the Falcon 9 posts. See Nuclear right there, 1, 2, 3, and 4. Guess what those hold? Hold down points. They're static hold down. See them right there? That's a processing stand. A vertical processing stand for Falcon 9. That's where they fold the legs up, and then they take them off, and they put them on the transporter, and the transporter drives out here, takes a right, goes past Space Hab, right? Or former Space Hab, and then drives through here. That's where that picture was taken. And then it goes all the way. All the way. Yep. Still going. See that road right there? To Roberts Road, which is right there. See? Or it could take the NASA Causeway. Take a left at Albuquerque and go across here. Falcon 9 processing area is the one that we've been looking at KSC. Remember, you know how, I don't know, Nuclear, if you've seen me go on spiels about heavy graded roads and how they work and stuff, but long story short, it's really easy to see that this is the Falcon 9 processing area because the picture literally has the Falcon 9 with a Falcon 9 with a transporter sticking out the side. I never noticed that. At what speed? It can go like 5 to 10 miles an hour. But see, there it is. There's the exact transporter. There's that. Fun fact about this thing, though. You see that transporter? I said that that's the original shuttle transporter. And I know people, that doesn't make any sense. Like, check this out. Here we go. So there's the transporter, right? There it is in 1985 on the other side of the country at Vandenberg moving Enterprise around. Same vehicle. Not like the same type of vehicle. The same serial number. That's the same thing. They only made one. And then there it is in 2011 moving Atlantis to KSCVC. Right? And then there it is in 2016 moving a Falcon 9 back. SpaceX still uses that transporter. That Kometo has been in service with space programs since 1985. All the way to now. When the shuttle program ended, SpaceX bought it at auction. And the funny thing is that the auction was publicly disclosed. SpaceX scored that thing for 37 grand. 37 G's. SpaceX is using an X shuttle transporter to move Falcon 9 stages around. Pretty cool, huh? Oh yeah, that's the speed that it goes. Here, goalie has it. My guy. Thank you. Here, you want to see how fast it goes? It doesn't go very fast, but it can move a Falcon 9 around, so, you know. What did NASA use to move the shuttle before 1985? Its landing gear. True story. Yeah, don't touch it. Yeah, don't do that, Fleck. That would be a bad idea. And then goalie got me a picture of them hold down points right there. See them? Look at that flange, dude. That is a chunky piece of steel. I assume Falcon 9 is much lighter than an orbiter. Yeah, I think that would be a safe assumption, considering this gigantic steel jig that Falcon 9 is moving on. Yeah, I think that would be a right proper thing to assume. Yeah. You know what the thing is? This thing's probably not even near its maximum capacity. Orbiters are heavy. Remember, that orbiter was designed to move the shuttle potentially with payload inside, so we're looking at 100 tons. It's pretty sick, man, right? How do they condition and clean the boosters? Well, they don't clean the boosters no more, Flyke, and it's literally a pre-flight check. SpaceX has it down to a pre-flight check. Inspecting the welds. See these scuff lines right here? That's a weld inspection line. That's it. See the scuff marks? That's where they inspect the welds. Because this is aluminum friction stir welding, something that's an idea that NASA actually pioneered with the external tank. True story. Friction stir welding was something that the shuttle program, that came from the shuttle. But see all the seams? They inspect the seams, they do a couple of pre-flight checks, replace the T-tab as needed, and go from there. That's it, dude. That's all it needs. Got to take some things apart, check some things here and there, and then it's good. These things are... SpaceX has pushed these things to pretty much be reusable. It's pretty insane. They don't like hose it down from radiation and dust? Nope, doesn't need it. Most of that gets blown off. All this crap is just the soot coming from the open cycle Merlin engines. Isn't that something? She's big. So see that little hole right there? There's 9 of them on the inside. If you ever see Falcon 9, we'll watch Falcon 9 today when transporter goes off. Watch. If I can watch like right around here, you'll start to see flames crawl up the side of the booster because the fuel-rich exhaust from the turbo pump gets lit on fire by the excessive heat from the engine. So you'll see flames appear to crawl up the side of Falcon 9. That's nothing. It's totally normal. But then, when Falcon 9's flying through its own exhaust plume during the supersonic retro propulsion, yeah, all that stuff gets caked onto the side of the booster. What I'm trying to tell you is that Falcon 9 rolls coal. It rolls coal hard because of the open cycle. Watch. Watch this. We don't need the sound. Okay, so there's a dump on the side of the engine. It's an open cycle turbo pump. So watch this. Yeah. See the dump? Falcon 9 rolls coal, baby. Yeah, they run fuel rich for more power. Same reason. That's the exact same reason why diesel bros do that. You know, you ever see those trucks that shoot out the black flames everywhere? They do that to make more power because more power. This needs to do that though because characteristic energy delta V. You think you need some sound? All right, we can have it your way, Dr. Venkman. I probably should have said headphone users, huh? Alright. See the open cycle? So some rockets use that to cool the nozzle. They use this dump to film cool the nozzle, like the F1 Saturn V motor. See? They have the turbo pump dump into the nozzle to keep it cool because excessive heating was a really big problem with these engines. Yeah, they really didn't like being that close to each other, to be honest with you. Yeah, they really didn't like that. How many F1 engines popped on the test stand? I don't have the answer to that. That's one of my favorite pictures, dude. One, because Von Braun. Two, because this is one of the few pictures that generally denotes the scale of Saturn V. It is incomprehensibly large. You won't know until you go and see one. Von Braun was not a small dude, okay? Von Braun was 6'2". He was a big guy. He's a big dude. That's 190 centimeters. He's a big dude. And he looks like a freaking short person compared to this. I mean, those nozzles right there, the diameter of that nozzle. So at the end of the nozzle, that diameter, fellas, is as wide as that rocket. 3.7 meter nozzle diameter at the end. It's that big. Yeah. Mm-hmm. They're gigantic. Why is it black and sooty? It's fuel. It's carbon. You're seeing carbon come out. You're seeing all the freedom come out of it. No, they run fuel rich to keep it cool. More dirty. Okay. Oh yeah, see? Weld inspection lines. You can really see them here. See that? Well, actually what they're doing is they're x-raying the welds. And they have to clean that off to x-ray them. Yeah. Did NASA Rocketdyne ever create a smaller version of the F1? No. The F1 program was there to basically try and come up with a one-stop solution for an ICBM in the late 50s. They wanted an ICBM, a big ICBM, like with just one engine. That was the whole point. So they wanted to pioneer heavy lift to be able to just basically, I'm not going to say send a Saturn 1B sized rocket with like 1,000 different nukes in one shot, but that's basically what they wanted to do. I mean, it's very Fallout. Very Fallout. Hellfish, you'd be more interested in this. If I'm thinking about this correctly. You'd be more interested in that. A 40-to-1 expansion ratio F1. But it's not an F1. That's an M1. The M1 was a Hydrolox version of the same engine, dude. Crazy, right? Yeah. This was going to be the second stage engines on Nova. And they started making parts of it, dude. They started making it. Okay. For the fabricators here, I just want to point out how ridiculously good that TIG weld is right there for being done by hand. Because it was done by hand. Look at the uniformity of that weld. Nova to the moon. Oh yeah, Creeper, you showed me. Yeah. There you go. Yeah, look at the bungs right there. That's what they're called. I know. Look at the bung welds. They're perfect. That is perfect. Somebody did that by hand. And it's, dude, that is insanely good for being done by hand. EJ welding stream when? When I have the room for a welder. No, we'll do it. I'll do welding streams. So you guys can make fun of me. Until I get guilt tripped into actually making it right. Yeah. That's pretty much what's going to happen. Spoiler alert. Pretty cool, huh? Yeah, that's an M1 engine, dude. Actually, whenever I go and look and I see like shuttle engines in museums and whatnot, I always admire the welds because I know someone welded it by hand. Because maybe it was on a jig at best, but somebody welded all this by... That's all welded by hand. You can tell it's not completely uniform. A machine did not make that. That's done by a person. And that's pretty damn uniform for being done by a person. It's pretty freaking impressive. And I really, really hate seeing this thing outside. It really is annoying. Wait, has there been a house update that I missed? The appraisal is this week, dudes. Appraisal is this week. So no news is good news. Alright, so we have these hold downs. I know that these hold downs work. Some in summer, some in winter. Alright, I know that these work. But I have an idea for actually making a hold down system. Okay? So, how this is going to work, I'm going to take this and make sure that we just keep it down here. Right? I don't want that thing to get broken because we know that hold down point works. So let's get rid of this. So I'm going to do some things here. Okay? We got to make that pin and lock like Falcon. I'm going to see if this works. So we're going to move this up here like that. And the hold down point is going to be on the sides like this. And then I need this in 4x symmetry. There we go. And we need to make sure that that's right in the center. It has to be dead center. Okay. So now let's save this. And then we need, I'm actually going to copy this, right? And we're going to work over here today on this side of the post. What I'm doing is I'm trying to figure out reusable hold down points. The reason why I'm taking so long to figure out these hold down points, fellas, is, well, the SSDO hold down points. I didn't get them right, and that was the Achilles heel of the entire project, believe it or not. I've had nothing but 6 months time to think about why the SSDO program failed. And it really, really hurts because that's a lot of time. That was a lot of time invested. But one of the fundamental reasons why it didn't work the way I wanted it to is because it never interfaced to the pad correctly. That was one of the big ones. Trying to get this thing to hold up 1,500 tons didn't work. It blew up. It did work once, and then I couldn't get the landing thing figured out, but then we got the landing thing figured out, and then the pad exploded. So, Dude. I still want it. I still want it, guys. I'm not gonna lie to you. I still want to make it. That thing was so gnarly. Don't get me wrong. I like building my regular rockets, but that thing was awesome. Maybe I'll do it for fun if these ideas work. So I started to come up with the ideas because this thing flew great, believe it or not. It was the interface to the pad that always messed up because it didn't like loading up 1,500 tons of fuel and 20 tons of payload. It really didn't like it. Maybe it would be more viable in KSP2. How? Well, I mean, maybe if they work on the part simulation, dude. Possibility. Yeah, it's possible. So, I'm really making sure that my interfacing mechanism is the best I can possibly make it. So we never have a problem. So let's go over here. We're gonna work over here like this. And what I need to do is remove that from symmetry, remove that from symmetry, and remove that from symmetry. Okay? So we need to go 1, 2, 3. Okay? Now, we need to take this. We need to move this triangle up. Like that. Get rid of that. And now my hold downs aren't going to be exactly like Falcon 9. If it's one thing that I've learned is that don't try to make it exactly like the real thing. Some things in Kerbal don't really translate correctly. Okay? So, we're going to take these cradles here, right? And then I'm going to attach them. You need to make sure they're in 4 times symmetry, right? I'm going to attach them like this. And we're going to see if we can hold these suckers from the side. Like that. Cradle them. Just like Falcon 9 does. Right? I think this might work. Either that or it's going to fall right through because the thermometers can't hold the stupid thing up. Now, I know what you're going to say. Okay, so how does this hold down? What are you holding with this? Absolutely nothing, which is what you are about to become. Prepare to die. Yeah. It should work. I mean, I don't see why it wouldn't. But here, how about we go out and we test these? So let's go in here like this. Make sure that that has enable. And it's still picking up on the symmetry node there. Make sure that has enable. And then make sure that these are enabled. They are. Okay. Bound it to AG1. Let's see how this works. Let's see if it holds it. I'm interested. Let's bring this thing out. What time is the launch this afternoon? 2:30, Grayson. And if you bring up Bucky Dent again, I'm going to slap you. Or, if you bring up Bucky Dent, if you bring up Bill Buckner, you will get slapped. Okay? Don't do that again. I can smell pinstripe failure from here. Seriously, though, the Yankees are doing very well right now. The Red Sox are not. But that's another story. Is that Eastern? Yeah. Here. I'll give you an exact right now. So let's go over to rocketlaunch.live. So 227 for Transporter 5. And then Starliner operations for undocking should start at 2:36. So literally back to back. Falcon 9 is going to make it into space. That booster is going to land. And then undocking coverage will happen. Starliner will undock like almost at the exact same time. Yeah. Almost at the exact same time that Starliner will undock from the ISS, Falcon 9's first stage will land. That's what she said. No, that isn't what she said, okay? Undocking coverage will go live at 2. Yep. Thomas, we're going to have to double box it, dude. We're going to get the double box rolling. Red zone style. Who knows what I'm talking about? So, that is approximately an hour and 30 minutes from right now, Grayson. An hour and 30 minutes from right now. And if you're watching the VOD, none of this means anything. I hope it launched. Hi, VOD viewers. Okay, so, let's undo the struts and let's see how this holds up. Let me just make sure I hit AG1, just to be sure. Whoa. Huh. Okay. Okay. That's really smooth. Open up the vehicle stabilizer. Okay, free float the vehicle. Flip back, retract the umbilical. Redock. Close the VSS. I agree, Hip. Yeah. You guys know the next step. Okay. Mida Rockley, what am I building? Hold down points. I want to land my boosters like Falcon 9 or Super Heavy or even Starship. No, I'm not going to catch them. But I want my boosters to come back and land. And when I want them to come back and land, I want to put another payload on top of them. And I want to put another second stage, another payload fairing on top of it. So I'm developing a reusable launch pad here. And now don't get me wrong, you guys have heard that spiel from me for 1,000 freaking different times. This time though, I'm really trying to put it through its paces to make sure that nothing breaks. I'm trying to make fully reusable regular, like Falcon 9 styled rockets, Rockley. Like go up, come back down, land, and then I can build a crane in this game. We could pick it up with the crane and put it right back on the pad. And then fly it again. The funny thing is, dude, and this is the thing about reusability that not a lot of people know. Parts bend. There's metal fatigue in KSP. Parts do bend. That happens. But the thing is, parts bend, but not physicsless parts. So that's where this is kind of coming into the fold here. I'm trying to make hold down points out of physicsless parts. Now, if that made no sense to you, just go with the first spiel. The launchpad spiel. Pixel fatigue, indeed. We are encountering a fair bit of shaking here at the vehicle. It's not a bug, it's a feature. A feature of physics, I'd say, nuclear. Okay. Once this is fully topped off, those hold down points that we just engineered right there, the ones that I had from bumping my head, are They're holding up 260 tons, and they don't seem to be jostling around as much. They are moving. All right, here, let's undo the tanks. Retract the vehicle stabilizer. And then free float the thing, which is something you probably should never do, but... Wow. Damn. Yeah, the futuristic stuff in KSP2. So that part is freaking out because it's colliding with the vehicle a little bit. It won't freak out as much if we do that. Ready? But this might cause an explosion. Yep, that did crack and strike. It absolutely did. Did you see the, on reload, did you see that fuel tank jump? It crack and struck. We do need to come up with a better umbilical, but bring the VSS back into position. She's wandering around just a little bit. Watch, ready? I'll bet you doing this bends it back into position. Hey, Loopy. Loopy, I'm pioneering something called hybrid tech. So what's hybrid tech? All right, here, let me show you. Why am I using that down there? Why am I doing this? Why am I trying to reinvent hold down points and stuff? Well, Loopy, you know how parts drift in KSP. Robotic parts drift. If you crash something into the side of the VAB, parts will bend, right? Well, I have this theory. Physicsless parts don't drift. They don't, because they're physicsless. All right, it's kind of a weird logic fallacy in KSP. Physicsless parts don't drift, right? They're physicsless. But, Loopy, we figured out a way to make physicsless parts collide with each other. Now, I know you probably know this, dude. You probably know that if you attach a physicsless part to a robotic, that you can trigger same vessel collision. That's nothing that Repo didn't tell us when Kerbal was still being worked on, right? But consider this. So this is a modified version of the tuk-tuk. You remember that? Kraken Tech plus breaking ground. Yeah, but we took it to the next level. Remember how I said hybrid tech would probably be the best way to do things? But I couldn't get it exactly right because we couldn't make Kraken bearings, right? We couldn't make our old Kraken bearings. They wouldn't work. They wouldn't work correctly because they're Kraken bearings. Well, we found a way to be able to make robotic or physicsless parts collide without being attached to a robotic part. I'll say that one more time. We found a way to make physicsless parts have same vessel interaction without being attached to a robotic part. So, if I have hold down points, for instance, that are made out of physicsless parts with same vessel interaction on them, you can make one vessel. You can make one vessel that uses Kraken tech. It uses Kraken bearings, and it'll work exactly the same. Case in point is this vehicle right here. So this is a modified version of the tuk-tuk, right? Now you notice it has physics balls attached to it, right? Watch this. Well, Chat, let's hope it works today. So we power up the helicopter engines, right? That should be pretty normal, right? You power them up and then you take off, right? Now, to launch news. Okay, yep, a little busy right now. Hey, Tara, nice hat. Thanks, man. Yeah, it's covering up a gigantic scab on the top of my head from where I headbutted a cabinet last night by accident. You know about that. So, Loop, watch this. So you notice that there's gears right there. Remember the gearboxes that we used to make? Watch this. And once again, let's hope it works today. Ready? This thing is being flown off of one engine. Look, no power. No power to the right motor. But the left engine is powering both the left and right motor because I have a drive shaft that's made out of gears that's attached to a rotor that's attached to the other gear. I have a synchronizer gear between my blades. And now they're out of sync because we skipped a couple of teeth. But hey, you get the idea. This was just a tech demonstrator, right? Now if I reintroduce power back into the design, we can fly on two engines. See that? We have a synchro. I have a synchro. And we have a gearbox that, well, it broke because it bent out of shape. But once again, that was just a tech demonstrator. But there is a gearbox that holds this whole freaking thing together. And now instead of this tuk-tuk, just on a side note, instead of, you know, using jet engines and gyroscopes to hold itself in place, this tuk-tuk has no SAS on board. Look, no reaction wheel authority. This is all the rotors doing the work. Just on a quick side note. See? But there's a Kraken bearing holding all that together. The gears skipped a little bit. And that sometimes happens when you put it through its paces, but still 100% flyable. So, we can make synchronizer gears. So you can have one engine powering a bunch of rotors if you really want to, right? Another example of hybrid tech working really well, would be from another project, Loopy. I don't know if you were here for that. That's just physics slip and discussing a NASA payload on... That's just the Psyche slip and discussing a NASA payload on transporter. Yep. Yeah, the Psyche slip because the payload... Yeah, I gotcha. Cool. Loop, you see what I'm doing here? Now, more importantly, you see what I'm doing? You see the potential of this? Let me show you another example. Chungus, the crane. Remember the crane? Remember how we couldn't get it to work? Watch this. Remember the spectro bearings? The cool thing about physics-less parts is that if you have physics-less parts and you tell them same vessel collision, even if they're clipping, they won't react with each other. But if they're not clipping, they will, which is very interesting. This is a really weird phenomenon. And I still don't fully understand it. But watch this. Remember how we couldn't get the crane to work because everything kept deflecting, everything kept bending. Watch this. Loopy basically, or not Loopy, Wheatley, sorry, I didn't get you two confused. I'm excited about this. Alright. The crazy thing about this, watch what you can do. Take a look at this. This is big. This is a big thing. This is just as crazy as the first time we came up with Kraken Tech. Watch this. Let me pull that back. So these are a Kraken Tech assisted hinge with a robotic. The robotic is still the pivoting part. We don't need any torque on that thing. And then this thing up here, you don't need torque on that. And then we have a Kraken Tech pin that we're using down here. Hinges stay perfectly in place. 9 tons at the end. Any crane operators? Goalie. Tell me how ridiculous that is. How much shear load we're putting on those hinges. Hey, RG, what's going on, man? Look. That's lifting 9 tons of fuel off of the end right there. Cranes don't do that. Cranes do not lift like that. That's not how it works. Because that thing has maximum moment over the crane. Remember, you got to make it so the counterweight balances. This has a 9-ton counterweight that's 1 thumper distance away from the pin of the crane, from the pivoting point of the crane. That thing is a thumper and a kickback, so it's 2.5 times the distance away. When you lift like this, it puts an insane amount of shear load on these hinges. And the hinges take it. They take it just fine. Hey, Grav, what's going on? So, fellas, this isn't just good for making cranes here. We can make cranes on other planets. Cranes on the moon. This will work. I mean, as long as this works here, it'll work on the moon. It won't drift. These pieces will not drift. They don't drift. They won't move around because the load is not on the hinge. The load isn't on the hinge. It's on the Kraken tech. And if the load is on the Kraken tech, that means the hinge won't drift. Because physics-less parts are bearing the load. And physics-less parts do not drift. Watch. Time warp. Fizz warp. Wait for it. Look. We fizz warped that. That would have broken. Any other scenario, this thing breaks. Even Eve? Sure, why not? See, you could see the robotic wants to drift, but the second it tries to, it bends the hinges, and the hinges are way stronger than the robotic is. That would have broken any other crane design we've ever done. Easily. Easily would have broken it. Works just fine. This thing is bending and flexing back and forth. Guys, if a real crane did this in real life, it would shatter. It would look like a Kraken strike. Now, the crazy part about this is that it's not just left to right motion. The whole thing is mounted on a gigantic servo. Watch this. See how strong these hinges actually are? They're insanely strong. And then if we went crazy and did same vessel collision on top of that, thing would be freaking be even stronger. You could use this for Kerbal exploration. Non-robotic hinges. Robotic hinges that don't drift. And Kraken tech hinges that are 1,000 times stronger. And because they're physics-less parts, they don't drift. They won't drift. Dude, I fizz warp, time warp that thing. Time warp, untime warp, right to fizz warp, unfizz warp. That would break anything. That's like an earthquake for anything in Kerbal. The thing is just like, ha 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 ha, I'm not going anywhere. So, I'm trying to develop hold down points for my launch pad that don't drift. Because if you develop hold down points that don't drift for your launch pad, you don't need to worry about stuff getting bent when you go to reintegrate a booster. You can make a better transporter erector for a rocket. Yep. RG, you see what I'm saying? You see what I'm building here, right? Look. We'll put it through its paces again. Time warp. Nope. See, it tried to. Popped right back into shape. The parts don't drift. They don't drift. Now, I'm not going to say that this thing is insusceptible to a Kraken strike. Everything is susceptible to the Kraken, but there's better ways to safeguard against it. Hey S, what's going on? So, non-driftable hinge. So, Loopy, Wheat, guys, where I'm at is I'm trying to use hybrid tech. I'm trying to make equipment that is insusceptible to robotic drift. And honestly, if I had figured this freaking thing out with the SSTO, I could have made the pads work. The pads would have been 100% reliable. The pads were the problem with the SSTOs. The SSTOs worked fine. They were great. Could you try to induce a Kraken strike on this crane? I just did. I just tried to. Ultio, we just went from Fizz Warp, or Time Warp out of Time Warp, reloaded physics in a blink, and then immediately went to Fizz Warp and unloaded Fizz Warp in a blink, and then went back to Time Warp. That will break anything in KSP. Any of my designs in the past, that would break them. They would snap. Yeah, dude, it's a big deal, fellas. It's a very big deal, and I'm really happy that we figured it out, because that could help me fix a lot of SSTO stuff. In fact, we could fix them right now if you really wanted to. You want to take a stab at it? Here. Let's go open up the mission mode save. Let me get LV5B. Let me get the LV5B or LV5A pad out. I'll show you. I'll fix the small SSTO's pad right now. No drifting. Or no, the MLV. We can keep working on that if you want. It would take 2 seconds to fix this thing. There you go, Shep. Nice. You can fix it, but we're working on the MLV. Yeah. I'll go into the pad and I'll show you. Big thing is all these hinges that we're using. I tried to couple up the hinges to get them to be strong. If we did hybrid tech here instead, it would never drift. Never drift. Never have a problem. Hybrid tech would fix this. So 1, 2, 3, 1, 2, and 3. If I just did same vessel collision parts there, never drift. You'd never have an issue. We'd need some there, and then probably 2 down there as well. It would never drift. The pad would work. And then also, if we did some physics-less parts off the bottom and made some alignment pins for the SSTO, it would be gnarly good. Yeah. And then maybe some for the TE as well. But the part count would go up pretty high.
Discovery, go at
Hey, Isbek. I expect the MLV to be completed by 24 months, 19-month resub. Maybe we'll do this a little bit later today. I just want to play Kerbal and do rocket stuff today, guys. I don't feel like playing anything else. I want to watch Transporter. I want to watch the Starliner undocking, and then I want to play Kerbal. Guys, I was thinking about this last night, dudes. We need to play more KSP. I want to get back into doing space stuff. I've enjoyed my 6-month, give or take, vacation from KSP after 10 years. I'm good. I'm good. Let's get back to work. Enjoy the day just rattling you? No, it's all good, man. I want to get back into building it. I needed to take a break, dudes. And I kind of want to get the that SSTO working just because frick off, we need to get it working. Actually, messing around with these pads probably isn't the worst idea, fellas. And the reason why it's not the worst idea, okay, so just hear me out for a second. The reason why that's not the worst idea is because screwing around with these pads will help me prove that these hinges aren't driftable. It's more research into the hybrid tech system that I'm trying to figure out right now. And that could actually help us. That could help us when we go to build a different rocket.
Discovery, go at
Shep
throttle
gifted
up.
a sub to Blue Hawk. Thanks. The large SSDO Novacon works. Problem is the pad. Pad doesn't work all the time. But it does work. Oh yeah. I have the large SSDO out on Kerbal X right now, guys. If you just use it as a regular vehicle, like put it out on the launch pad, hit the go button, right? Launch it up into space and bring it back down, it'll work every time. We figured out end-to-end mission for that thing. It works great, believe it or not.
Discovery, go at throttle up.
Azamalak, thanks for gifting a sub. I appreciate it. Version 8, here it is. So this was the final version of the pad that we made. Oh yeah. Oh yeah. Oh yeah. Yeah, this can be fixed. Dude. Oh my goodness. I'm seeing places where the hybrid tech can be applied left and right, and it's ridiculous. So did an old career with Jetstar and Freedom get put on hold or just retired? It's on hold, Loopy. Mission Mode 2. I needed to do a revision, dude. Right around December. The holidays, just combined with the stress of Mission Mode, I hit a breaking point, and I needed to take a full-on break from KSP. I probably shouldn't have done that in hindsight. Like, we're 6 months behind where we should be. But I potentially wouldn't have figured out the hybrid tech solution. So it's probably for the better. So I've been variety streaming pretty much while you've been working at the shop, dude. Yeah. Just playing Railroad, Satisfactory, bunch of other things. Alright, let me mess with the title. Fixing an old pad with new building methods. What was the last major thing to happen in Mission Mode? The last major thing I did was launch a payload and have it fail miserably in the middle of the night, and I got really upset about it and promptly rage quit the stream. That was in December of 2021. Haven't really done some serious Kerbal play since. I got really annoyed. I was like, I gotta take a break. Alright, so this was the last version of this pad. I remember that launch. Yeah, you were part of the reason why I freaking got annoyed, Jim, you jerk. Yes, this is your fault. Alright, so let's go launch pad R9. 5, 25, 22. Okay, how would we go about fixing this, and what bearings would we use? I have to go back and look and see how this all came together. Okay, so the hinges were attached to a piece that's... okay. And then that one is too. But the main ones aren't. Alright, so... how did I make the hierarchy work? Attached to the hinge is the I-beams. Okay. I attach the I-beams to the hinge. Okay. Alright, we don't need that. We don't need that. We don't need those. None of that is needed. Where's my rotational debug controller? We don't need that. Launch table rotational controller. Yeah, we don't need that. We don't really need that either. I probably shouldn't have got rid of the other one, but that's okay. I can always remake it. So we have the strong back control right here. And then we have the table control right here. The problem is that hinge, those hinges would drift left and right. They were terrible. So here's what we're going to do. Give me that launch table rotational debug controller. Oh, that's just the straight rotational controller. Do we have a debug controller? That's the master rotator. That should rotate the whole... yeah, okay. Okay, okay. All right. I'm pulling out all the stops here. Actually, it would probably be better to attach these to here. So we need a set of strong hinges here in the center, right? And then we're going to need another set of hinges outside for the launch table. That's its pivoting controller right there. And then those need to be connected on those I-beams, right? So this is the strong back hinge right here. So let's do 4 of them, right? Now, here's how hybrid tech works. Here's the secret sauce. So these are all attached to a robotic controller. So what I can do is I can go into action group 1 right here, and we can enable same vessel interaction, right? You got same vessel interaction on all these parts. Now these parts are collidable. Here's the crazy part. If I take them and then attach them to something else, check this out. The flag for toggleable action group stays. So you don't need to attach physicsless parts to robotics anymore to get them to interact. You could just, once they get attached to the robotics, right? Once they get attached to the robotics, you can you could trigger the same vessel collision flag no matter what they're attached to. It stays assigned to part, which is super useful. Long story short, we can use these as a hinge. That's the easy and simple way of saying that. So now what I'm going to do, I'm going to go in here like this. And now I'm going to make a second hinge set over here.
Discovery, go at throttle up.
Remember, they got to stay attached to their respective parts. Hey, FX. I have a question. I've been trying to make a man lift like an Ultra Boom and has a mass of 19,717. I'm using the TR2L ruggedized wheels. For some reason, every time I launch it, it shakes around at least one, sometimes 3 or 4 of the wheels. Do that thing with the rubber part. Brakes, the rover. Spring rates. Your spring rates aren't right, Creeper. If wheels start bouncing around and then break, that's Kerbal's way of telling you that you don't have enough wheel. Some wheel and spring rates, if they're set to automatic, are going to change to different values. Make sure you screw around with your spring rates. FX, 32-month resub. Thanks, man. Alright, so the outside set of RCS should... Yep, there we go. Now let's go over here. Save. And now I got to open up another craft file here. The craft file that I'm going to open up is the Chungus file that we have, the Chunguska crane. What's that, Ark? Slide of future upgrades to Virgin Orbit system shown by Jim Simpson. Oh, cool. We can check that out a little bit later. Hang on, it's loading 582 craft files. If we go get the Chunguska HT hybrid tech, and then I'm just gonna take these hinges. Got them. Put that there. Get rid of that craft file. Now that's the strong boy hinge right there. And because they come from this, see? Enable same vessel interaction. The flag is already toggled onto that part. So now what we can do, we can go in here like this. And we can take the I-beams. Now we're in symmetry. Now we take these pieces and we move them into position here. And we make sure that they're straddling those bearings. The axle that we made out of RCS. We make sure that they're straddling it. Now, do the same thing. Attach these to the outside here. Round the outside, round the outside, round the outside.
Discovery, go at throttle up.
Now we're going to straddle those. Now we have super, super strong hinges here. And now I can take the structural tube and we grandparent strut them to root. Which means they're strutting to the root launch table part right there. And if we really, really want to make these strong, I incorporate the same system that I had before. Where we have these things, these I-beams basically clipping into the ground a little bit and being used as a holder. Now, this is a little bit more parts, obviously. A little bit more parts. But this is going to be ultra freaking strong. About as strong as you can make hinges in Kerbal. Because, once again, physics-less parts. And as you know, EJ proposes, and the Kraken disposes.
Discovery, go at throttle up.
Cryptech, 31 months. Thanks, man. These might need to go up one. Nah, we'll keep them down. Now what we have to do is just go in here. Take these two parts, right? And we hold them together, just like the real one. And we're gonna have to go. These parts might not even be needed, now that I'm thinking about it. But if they are physicsless, I would think they wouldn't lag as much as the other parts with physics. NeoQ, I actually haven't gotten that far into testing to know for sure if that's what's going on. It's possible, dude. Yeah, very possible. So that one's going to need same vessel interaction, but I'm not 100% sure, because that's the bump stop to hold it up. I'm not 100% sure how that's going to jive with the hinge. We'll have to figure it out. I hope the SSTO is dead for good. Thanks. You know what the crazy thing is, King? This isn't even new. This is hinges that we made in 2017. It's more of a revitalization because they work. I know they work. Are we going to test this with the SSTO? Well, I got to do the fixes to the pad first, but... we'll just leave that like that. Once again, I'm not 100% sure how well that's going to work, but we'll see. If we really wanted to get fancy, like really wanted to get fancy, what we could do is this. But once again, I'm not 100% sure how well this is going to work. You know what? Let's do that without it and see what it does. When does that transporter launch? About an hour, Steiner? Docking coverage begins in about 20 minutes for... or undocking coverage begins in about 20 minutes for Starliner. That's some tight timing. Loopy, when Falcon 9 lands, is when Starliner is going to undock. Yeah, within 30 seconds of each other. It's gonna be a pretty crazy day. I'm ready, dude. Love space. It's so simple, but the coolest thing to me was the panels working like a real heat shield to spread the power. It was wild, wasn't it? The arm and this are the arm and the transporter are slightly out of sync, but that's what it is, Alice. It's not a mobile launch platform, it's just a launch pad. It's a launch pad for one of my older SSTO designs. Alice, you may have recently heard me speaking about how, ooh, it's binding. She's binding. Why is she binding up? Huh. Give me 1 second. So Alice, yeah, this is an old launcher. That's what it is. It's an old launch pad. Is it that? It is. Oh, it was the SVI on that thing. Okay. Yeah, the SVI was binding that hinge up. Okay, cool, cool, cool. Are you going for vertical or horizontal integration for the MLB? It's MLV. Ideally vertical, Dragon. Horizontal is difficult. But it might not be as difficult with these hybrid tech hinges, which is why this is such a big deal. How's the build coming? Sile, it's coming along okay. Alright. 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 We're going right to it. We're gonna do it. We'll just do it right now. We'll do it live. Frick it. We'll do it live. Frick it. Frickin' thing sucks. I want to get this in before the docking coverage starts. We're going right to 11, dudes. Let me get the small SSTO mastercraft file. Last, okay. In a few seconds after booster landing is when Nanorack's experiment starts up. It will cut some stainless steel and specifically the type used on Centaur stages for future wet workshop stations. Part of the mission is known as the Outpost Mars Demo 1. Cool. Okay. Here's what we're gonna do. I'm gonna fuel this thing up. Fuel up the pad. We'll start with the pad pre-fueled. Okay, put it out. Do we still have the structural testing article we made for this thing? That was actually for the bigger pad. I don't have the STA. No. I never had a structural testing article for the small one. Which is ironic, Loopy, because the big one is what had structural testing problems. It had structural problems, and I made an STA for it, which is weird. Huh. Oh, I missed a set of wheels. Those little wheels were like, why am I being used to hold this whole thing up? SpaceX audio is live, okay?
Discovery, go at throttle up.
Hey, Vega. 14 months. How are you? I'm good. Procrastinating from work, the usual. Make sure you get your work done, okay? Any update on the house? Nothing right now, Chris Station. The bank is appraising the house. So right now, honestly, no news is good news. Okay, W. House, I hope everything is okay. Steiner, Brimo, and I are trying to... We're looking to buy a house. Yeah, we're looking to buy a house, dude. I managed to hurt myself doing housework yesterday and replacing the broken window unit even with help. Yeah, Loop, you gotta be careful, buddy. Wait, what did you hurt? Hold on. Don't tell me you hurt your back, dude. Because if you hurt your back, don't go anywhere. Serious about that, dude. Don't do anything. No, I just tweaked my foot funny while going down the stairs. Oh, okay. It's just fine. It's sore. All right. Just be careful. Yeah, that's how I slipped a disc in my back lifting an 18,000 BTU air conditioner by myself because herder strongman. Yeah, that didn't work. That wasn't a good idea. Oh, a little satellite in there. That's neat. SpaceX just called a hold on Transporter 5. You sure? You sure they weren't just going through the ground procedures? Hold. Yeah, Dragon, yeah. Stupid stuff like that. It's time for jet truck. Did you guys miss jet truck? Are you covering Transporter 5 or nah? Yeah, of course I am, dude. Why wouldn't I be? 30-minute hold for thermal checks. Makes sense.
Discovery, go at throttle up.
This is cool. You want to start making this stuff? Well, KSP, it's all fine and dandy, but you gotta remember, it didn't work. I'm running through this quickly, which is probably not a good idea considering it's the SSTO, but well, she docked. Hopefully it doesn't blow up. Nope, didn't blow up. Okay, air brake alignment controllers down. Let's see if I remember how to do this. And broken wheels. Nope, she didn't break. Thanks for the spectacular vibes. No problem, Black. 33-month resub. James, 33 as well. Thanks, guys. Well, we got a problem, fellas. We don't have the pin aligned. But in the name of time, I'm going to do what I know is a known failure mode. But we'll take our chances. We have to get that docking port. See the two docking ports? They need to align, and they need to dock. Okay, they're docked. It's a known failure mode because I have a habit of not readjusting the friction controller on that thing. There. That's good. Readjust friction controller. Set that back to 1.0 where it was on override. Okay. Okay. Okay, we're all hooked in. Gear up. Enable the master rotation controller.
Discovery, go at throttle up.
JT, Transporter 5 news. Transporter 5 countdown is being held to allow for additional thermal testing of the PMM used for payload deployment. Okay. That's normal. Now we have to start cycling the fuel tanks. X200s, X200. Mark 125 adapter. X200, X200-16, X200-32. We're still missing one. Got to find the open fuel tanks. There's an X200-16er right there. There's another X200-16. As long as there's white lines pointing to the SSDO, that's how you can tell that there's still fuel tanks in here that need to be pinned. The Oscar B fuel tank is no problem. Missing one last one. Mark 3 or Mark 2 fuselage short. Okay, shut off the oxidizer. Fueling procedures is what used to take so long with these damn things. I'm missing one tank. Let's go in here and see if we can find it. This thing is just clustered with fuel tanks. They're everywhere. That one's already selected. What about you? That one's already selected. Okay, other side of the SSTO. Okay, that one's selected. What about you? Bingo. There's the missing one. We need 4 X32s, 4 X200, or no, 6. I forget, man. Those are the front tanks right there. Yep, okay. No, we got all of them. Okay, cool. Let's fuel this thing. Yep. So 1, 2, 3, 4. There should be 4 X32s. 5, 6, 7, 8. 9, 10, 11, 12. 13, 14, 15. Yep, okay. Let's try to fuel this thing. Okay, we've begun fueling. New T0 of 235. Hold is expected to last around 25 minutes. Got it. They just want to watch the Starliner undocking. Alright, I'm doing another no-no. Okay, we're fully fueled. Okay. See, look. See? There's the problem. See the jiggling around? That's the problem. That's why the SSDO program didn't work. At least that was one of the big reasons. Okay? Cut out the fuel. Disable cross-feed. Engine chill down. Engines are reading not a full fuel load. We're missing some fuel tanks. We didn't get all of them. Damn it. What did I miss? They're not reading full fuel. I know, it's a pain in the butt with all the fuselages, especially since the pad is made out of them. No, that's fully fueled. Here, let me try disabling crossfeed on the second docking port. Oh, yep, nope. We're good. Okay. Rocket's fully fueled. Undock. Game broke. It wouldn't undock that port. It got a little sticky. Okay, lock out the master rotational control. Master rotational control is locked out. Reverse the TE controller. Transporter erector. There it goes. Thrust vector checkout. Wiggle test. Okay, master docking port is armed. SAS enabled. Make sure we're set for the prime control point. Controlling from master. Alright, let's see what it does. T-minus 10, 9, 8. Oh, hold on. Gotta wait. Hold. Gotta wait for that to go all the way down. Oh, we have to do a pin lockout as well. I forgot about that. We gotta go in here. Pin lockout or else it's not gonna work. And that's broken. Okay. Did we latch the bottom docking port? Yeah. Alright, let's see what it does. This is not what you should do in real life. But, T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh, boy. Yeah, see that little piggly wiggly out of there? That was no good. But the hinges did hold. You see it wiggle out the pad? There's other ways we can fix that. We could fix it with other lockout hinges. Actually, everything looks pretty good here. SSDO still flies very well. Is this the SSDO? This is the small one, yeah. Actually, it looks really good. Right through max Q. Vehicle is supersonic. Interesting. Then what the heck is the big one? It's like 3 times or 4 times the size of this, and it has a pad that's 3 or 4 times as big. Okay. Throttling back. $1,500. Everything's looking real good here. Slow her down. Do we have a good apogee established? Yeah, it's not bad. I might have enough fuel. I forget how to fly it, so we might not make it, fellas. Like, I'll be honest with you, we might not make it. Shouldn't really want to do a radial in burn like this, but towel. There's no towel with this thing. Okay, stand by for Miko. Okay, we have engine cutoff confirmed. Okay. It's the price that we pay for lugging all this crap up here. 100 bits from Mav. Thanks, man. I pushed apogee too high. We have the Delta V, but I don't know if we're going to be able to execute that burn in time. The whole point was to get away from the pad, get out of render range. I want to reload the pad, and I want to see what happens. So if it doesn't make it, it doesn't make it. It's not that big of a deal. I wasn't expecting myself to be able to fly this thing correctly. It's hard to fly. This is not an easy vehicle to fly. It turns out when your vehicle is shaped like a giant wedge of cheese, it doesn't fly very well. Now you're hungry? Starliner will not undock for a little bit, but I will start popping up with the coverage here. SpaceX delayed the launch just a little bit. NASA TV should have picked up the coverage here. Yep, there we go. Oh yeah, that's cool. The segment that's about Jeb. That's awesome.
Discovery, go and throttle up.
It's the orbiter maneuvering system, guys. I chose small thrusters that were efficient for what they are, for the weight. This is like the OMAC thrusters on Starliner. It's very similar. SpaceX's launch did get delayed a little bit. They pushed out for additional thermal checkouts. Whatever that means. Yeah, we should have the Delta V to do this. Yeah. Perigee is -28 and increasing. We are past apogee here, though. So we have to do a slight radial out to compensate for being past apogee, or else we're going to get thrown into the wrong orbit. But yeah, see, we're just sipping fuel. No problem. "20-minute vent on Falcon." Got it. We have positive perigee. Come on, baby. I forget, Hired. It's been so long. Not bad. I mean, this isn't bad. I have 130 Delta V. That's enough to get it back down. We would not have enough to go to the station right now. Perigee's above 25. Perigee's at 40 and climbing. Once we get above 70, we can shut off the burn, the thrusters for the burn here. The design streams for this were great. It really is a pretty cool vehicle for what it is. I'm, like I said, I ain't ashamed of these things. It's some of the best engineering I've done. Hopefully we can surpass it with MLV and stuff. 57, 58, 59. The undocking has started on Starliner. Oh, I know. I have it up on the other monitor, man. See? Okay, that's up in orbit. We can bring it back down later. I want to go back over here. Let's go to the Space Center. And now let's look at that pad. We did break a piece because we slewed off the pad. That space plane was nice. It's Venture Star, K-33, and Jeb Star. It's Venture Star. That's what it's supposed to. Actually, that one's supposed to be the X-33. Now, okay. Yeah, let's just look at the pad. Fly on the pad. We're showing an interior. I have an idea for the building on the server and up on Discord. Okay. Let's just see what the pad does. Let's see if we're looking for it bumping around or if it wobbles around at all. It shouldn't wobble. It should just sit there. It wobbled around just a little bit. Let's check the hinges. Now we'll know if the hinges drifted a little bit if they're not basically perfectly coplanar inside of each other. Wow. Yeah, they didn't really drift. They did a little bit. It's not exact, but it drifted a little. But it ain't too bad. Yeah. Yeah, see, there's just a little bit of drift there. But they didn't really drift at all. Let me lockout T, rotational control, launch table, rotational control, reversed, enable. And re-enable fuel here. See what she does. Yep, it blew out one of the stilts right there. Now, part of the problems that we'd have is this thing would bend left and right. If it comes in and it's perfectly aligned, no hinge drift. Wow, 1/10 of a degree of roll. That's perfect. These things did move around a little bit. I can see them. They're not exactly aligned, but if we gave these things the same treatment as that, they'd work just fine. Heck, we don't even need a hinge there. You don't even need that. Just attach this thing to the side and then attach RCS to that and boom, Kraken bearing. Did these drift down here? Yeah, they did. Just a little bit. Master hinge didn't really bend though. Okay, cool. We will mess with that more after Starliner and Falcon 9. There's more things I can upgrade with the alignment mechanisms, dudes. There's way more things. But anyway, I'm going to get us into a double box of Starliner and Falcon 9 here. The SSTO is fixed. The pad is fixed. At least parts of it. Oh, you guys want to see the big one, huh? I'll show you. For the people that haven't seen it, that's the small SSTO. I'll show you.